This is Gail Kovac with Gresham Barlow School District. This is summer school, high school credit recovery, algebra 1A, and learning target number 3. I can solve and graph 1 and 2 step inequalities. So an inequality is kind of like an equation, but in this case, x is not exactly equal to one particular value. X will be equal to a range or a group or a set of values. And you need to find what all those numbers are and express that answer both as an inequality like this up here and graph all the possible solutions on a number line like this. So let's get started with this one. This is pretty similar to solving equations like what we did before because a lot of the steps are the same. What I want to do is isolate the variable by doing inverse operations to each side, treating this inequality like an equal sign. It's not equal, it's less than or equal to. And this one is less than. Greater than goes in the other direction, and greater than or equal to is in that direction with a line underneath it. So we're going to start by isolating this x by taking care of this minus 5 first, and then taking care of the multiply by 3. So for this minus 5, the additive opposite would be plus 5. I'm going to add 5 to this side, and I'm going to add 5 to the other side of the inequality sign. Minus 5 and plus 5 are opposites and cancel. So on the left, we will have remaining 3x. And it's not equal to, it's less than or equal to, and 1 plus 5 is equal to 6. So similar to what we did before, now we're going to take care of this coefficient out in front of times by 3 by dividing each side by 3, here and here. Times by 3 and divide by 3 are opposites and cancel. And now we're going to have x less than or equal to 6 divided by 3 is 2. This is how you express the solution set here as an inequality. And now we're going to graph that on a number line. So my answers, my solution set, are all of the numbers that are less than or equal to 2. So let's see, 1 is an answer. That's less than or equal to 2. Negative 1 is also an answer. That's less than or equal to 2. So is negative 2. So is 0. So is 0.5. So is 1.5. There's lots of answers. We're going to graph all of them, all of these dots all together, and basically just shade in the line because there's an infinite number of decimals in between here. My target value is 2. So this is where my solution set begins. Notice that 3 is not a possible answer because 3 is not less than or equal to 2. It's larger than. So this is where my solutions begin. This is my boundary point. Now 2 itself, is it an actual answer? Is 2 less than or equal to 2? It is because it's equal to. So I'm going to put a nice big circle right on 2 to show that that's my boundary point where my answers start. And I'm also going to fill it in to say that 2 itself is also an answer. Now, where are all the other answers? They're the values that are less than or equal to 2. They're all the ones going in this direction. So I'm going to shade in this whole line because here's where all of my answers are. And they don't just stop at negative 4, where my number line shows. This arrow shows that this keeps going on forever, all the way down to negative infinity. So it's all those values here. That's how you graph all of the answers on a number line. Let's try this next one. I'm going to do the same thing here. I want to do the same thing to both sides to isolate this variable x using inverse operations. Let's treat that inequality like an equal sign for now. I'm going to start by getting rid of that plus 1, and I'm going to subtract 1 from both sides of the inequality. Plus 1 and minus 1 are opposites and cancel. Let's see what we've got left now. On the left, I've got just negative 6x. And on the right, I've got 7, take away 1, which is 6. All right, now I've got this coefficient of negative 6 in front of the x. I'm going to need to undo that multiply with divide. Divide by negative 6, divide by negative 6. Multiply by negative 6 and divide by negative 6 are opposites and they cancel. So we're going to be left with here just the x And on the right side, we're going to have 6 divided by -6, which is -1. Now, something kind of strange happens here that we need to note. Whenever you are doing inverse operations with an inequality, and you happen to either multiply or divide each side by a negative number, that is going to flip the sign. It's like you just divided each side by 6, and then you subtracted 1 from one side and 1 from the other, and that ends up flipping your sign. So now, instead of the less than symbol, I'm going to have the greater than symbol. And I'm just going to write that note up here. If you multiply or divide by a negative, flip the sign. It's just one of those weird, quirky things in math that you kind of have to remember. So instead, now we've got x greater than -1. All right, so that's our solution set as an inequality. All values that are greater than -1 will work in this inequality. And now let's graph that. So all values that are greater than -1. Let's see. Well, here's -1. Greater than that would be 1. Yeah, that works. So does 2. So does 3. So it's all going to be going in this direction. My boundary is -1. This is where values start. That's where the solution set starts. But is -1 itself an answer? Is -1 greater than -1? No, it's not. It is -1. So although -1 is where my solutions start, like for example, -0.99 would work, but not -1 itself, we're going to leave this as an open circle like that. This one was filled in because it had an equal to sign. This one's going to remain open because it doesn't have an or equal to sign. And then all of the values that are greater than -1 lie to the right. So I'm going to shade here, and it doesn't just stop at +3, it keeps going all the way up to +infinity. So a couple of things to note here, a couple tricks. If it has an equal to sign underneath, that's going to be a solid dot to include that value in the solution set. If it's strictly greater than or less than, it'll be an open circle to show that that value itself is a boundary where the answer starts, but not actually an answer itself. As long as your variable is on the left here, then the inequality actually points to which way you should be shading. All the values here, see it's pointing this way to the left, so you're shading to the left of your boundary. This one, I've got my variable on the left, and this is pointing towards the right, so you're going to be shading to the right.